what we are learning in this topic. What we are learning in this topic. What we are learning in this topic. Have any idea? No. So actually, if you come across lessons order, okay, in your books, they give in particular order. First, we are going to learn about electrostatics. Electrostatics is a branch of science where we are dealing with the discussion of charge at rest condition and its influences. Electric field, okay, electric field strength like that, okay. Next, when the charge is moving with certain accelerations, uniform velocities. Understand the uniform velocities. In that cases, what is the Fx? Understand what is the effect? That is one discussion. And the charge is moving with a non-uniform velocity. What is the effect? That is a discussion. When the charge is moving with a uniform velocity, it produces electric field as well as magnetic field. Understand? When the charge is moving with a non-uniform velocity, it produces electric field as well as magnetic field. Along with it, gets some heat energy also. Understand? These are concepts, right? So in this case, actually, in the current electricity, what we learned, whenever the charges are flowing, current is going to be produced. After that, we have another topic, that is magnetic effect of current. Okay, in that what we are going to learn? Whenever the current is carried in the conductor, the current carrying conductor produces the magnetic field around it in circular orbit. Yes or no? Different theories given by different scientists, right? So current carrying conductor producing the magnetic field. That is one, right? So this is the topic where, okay, whenever the magnetic field is moving, changing, is that produces the current or not? If the current is producing a magnetic field, means magnetic field also have a chance of producing current. Understand? That is a scientifically, because energy cannot be created, cannot be destroyed. So, as the current is producing the magnetic field, means is the magnetic field produces a current or not, based on that. The different scientists done the experiment. That is the first one. Faraday's done the experiment. Okay. Based on the Faraday observations, we are taking the basic concepts. Okay. Then after Lenz. Okay, he's a scientist, he given some other conclusions. After that, directly we are going to the applications of it. Is it okay? Now, this is the discussion of this topic. Okay, in this, the competitive topic is motional EMF is the competitive topic, and force acting on the current carrying conductor is the concept, the competitive topics. Clear? Yes. So, first introduction. What we are learning in the introduction? First, okay, according to Newton's understanding. Clear? What he done is, while he is doing the experiments, okay, understanding what experiment, he taken one of the coil, okay, and the coil is connected to one of the galvanometer. Clear? Now, when he taken the magnet, which consisting of south pole and north pole, and whenever he is bringing that magnet near the coil, he observes some deflections. Yes, sir? And whenever you take the magnet, which consisting of south pole and north pole, you have to understand the magnet produces the magnetic field. It is the nature of material. Yes or no? Right? So, what is the way of magnetic field produces? Orientation of the magnetic field and strength of the magnetic field, that all things first you have to know before going to that, right? So, here you know that the magnetic field oriented, okay, inside will be from south pole to north pole. This is the orientation of magnetic field. Outside, from north pole to south pole. This is the orientation of magnetic field. Yes or no? And this one concept. Next, here, whenever you observe the magnetic fields lines, okay, these magnetic field lines are, okay, at near to the ends, means near to the ends means here at the edges. Understand? They are very crowded. They are very crowded. So arrow marks are wrong. Outside, no? This is inside. Okay. This is outside. Very crowded. Density will be more. Magnetic field density will be more. That means intensity of magnetic field at this point will be more. And as they are as they are moving away from this, what is happening? The intensity of magnetic field is going to be decreased. So that means this is according to geometry. What line this is called as axial line, and this is called as equatorial line. Yes or no? Along axial line, magnetic field intensity of the magnet will be more. Along equatorial line, intensity is less. That magnetic field intensity we are expressing in terms of using B. Yes or no? Yes. Right now, Now this magnet, whenever the magnetic field is producing, that means, okay, then it is brought near to the coil. What is happens? Now this is the north pole we are bringing, means this is the way the magnetic lines are going to be passes through that coil. Yes or no? Yes. So what the Faraday observed is, whenever the magnet is brought near to the coil, okay, so he observed that when the magnetic field is changing across this coil, magnetic field is changing across this coil, then he observed the deflection of the impulse. So based on that, he concluded that magnetic field is producing some current. Okay, yes or no? Current has to generate means there must be a potential exist. Potential difference has to exist. Potential nothing but we are calling as EMF, electromotive force. Battery is a natural EMF source. Okay, whenever you take in the battery provides a EMF. Okay, in the circuit, electromotive force it generates. Okay, it is a natural source. Natural means we are generating, artificial we are generating. Okay, in this case, what is happening? This electrode, the magnetic field is generating the EMF of the coil. Okay, what theories is stated and what condition he observed that current, that is a discussion here. Okay, so first, the magnetic field here, whatever the field is passing, okay, the field concept we are taking as a based on flux concept. Yes or no? What concept? Flux. What is flux? What is the meaning of flux? What is flux material? Number of lines passing through unit area. Yes or no? That means the group of lines passing through unit area is called as flux. Okay. So that flux may be magnetic flux, that flux may be electric flux, that flux may be water flux, that flux may be air flux, like that. Okay. So in this case, the magnetic lines are passing, so magnetic flux. How many number of magnetic lines are passing through area? There is something called flux concept. Yes or no? Can I write directly here? So the flux passing through particular area of cross section is equal to nothing but B into A. This is the formula you know that, I think. Yes or no? Flux is equal to magnetic field passing through unit area. Okay, yes sir. More the magnetic lines are passing through unit area, more the flux, less the lines, less the flux. Shall we go next? Now, in this case, why we are discussing the flux? Because as the magnet is moving, this number of magnetic lines are across the area. This is the coil area. Across this area is going to be changes. Okay, as the magnet is coming near, what happens? Number of lines are going to be increases. So there is a change in magnetic flux time to time. So that is we are writing as in terms of rate of change of magnetic flux. Understanding? The rate of change of magnetic flux is producing the current, that is explained by the Faraday. So current means first before the current EMF is generating. Okay, potential difference, that is EMF. So EMF is directly proportional to rate of change of flux, that is explained by the Faraday. Is it okay? Now, all the cases can you observe this? Okay, rate of change of flux means no. That is only concepts here we have to discuss. Okay. The first point is whenever we are moving the magnet, first we will come to the rest condition. Okay, whenever the magnet is kept at rest, rest means what is the velocity of this one? When the velocity is 0, whenever the coil is taken here, then what is the EMF across this one? EMF across this one is equal to 0. Understand? Because there is no change in flux. There is a flux is there. Flux is passing. Okay, there is a magnetic lines are passing. There is no doubt in that. But this number of lines will not be changes. As the time changes, these three magnetic lines are same, remain same. That's why there is no rate of change of flux. That's why no EMF. Understanding? Magnet. And next condition, whenever this same magnet is moving with a certain velocity, okay, that is constant velocity. Constant velocity, slowly. In this case also, what he observed is the EMF across this one is equal to constantly. If you are moving, still the EMF is 0. Okay, when the magnet is moving uniformly, what is happens here? In this case, the three lines which are there, okay, the number of three lines will be remains same in a particular small unit time. Understand? Clear? Later on, what happens? The 3 changes to 4, but rate of change will be very, very less. Rate of change will be very, very less. That's why it is not effective on the coil. That's why there is no EMF. Again, the number of lines, suppose 3. Later it becomes 4. That number of 3 to 4, it takes a long time. It is moving uniformly. Understand? Uniform. In that cases, when it is moving with uniform, what happens? There will be no EMF generated. That is based on force out on the conductor concept. Understand? So that means what is the EMF when the magnet is moving with constant velocity? Zero still. Okay. Next, when the magnet is moving with non-uniform velocity, that means nothing but having some acceleration. In that cases, what happens? There exists a EMF. That EMF is directly proportional to d pi by dt. That is explained by Faraday's experimental observation. He explained these points. Okay. That's it. Okay. So what is the final conclusion? Whenever the magnet is brought near to the circular coil, due to rate of change of flux, EMF will be exist across the coil. Okay. When the coil is at rest, no EMF. When the coil is moving with the uniform velocity, still there is no EMF. When the coil is moving with the non-uniform velocity, there is acceleration. Okay. Then there is a EMF exist. So he done the experiment by moving the magnet reverse also. In the case of reverse also, what is happened? He observed the same. That means whenever the magnetic field is okay, it means increasing. When the magnet is moving towards the coil, magnetic lines are increasing. That is called rate of increase of flux we are calling. When the magnet is moving backward, magnetic lines are decreases. That is called rate of decrease of flux.